This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. Welcome to section 5.5, day 2, solving exponential and logarithmic equations. Yesterday we did a whole lot of exponential equations, so today it's going to be the logs. Check this out. We've got log base 3 of x equals negative 2. So if you wanted to solve this, maybe the easiest thing to do would be to rewrite an exponential notation, and that's kind of the first strategy. So really, a log question asks, what is the exponent? Well, the exponent here is going to be negative 2, and this is base 3. The power is x here. And then you got to figure out what 3 to the negative 2 is. So negative 2, an exponent of negative 2 would really indicate that it's a fraction. This is 1 over 3 squared, which is equal to 1 over 9, which is 0.1 repeating. Now, another way to do this would be to graph it. You could take the left-hand side, and that is this, log of base 3 of x, and graph it. Now, if you're a particular grapher, it doesn't have a change of base option. Like, if it can only graph log of base 10 and not a base 3, then you have to change the base here. It would be log of x divided by log of 3. Desmos is awesome enough to be able to change the base, so really, if you're using Desmos, all you have to do is type this in. And then y2 would be equal to negative 2. So you plot these, figure out where they intersect, and they intersect right here. Bam, at the value that we calculated when we solved the equation. X has got to equal 1/9, and that's 0.1 repeating. If it is, then the value of y will be negative 2. Example 7, log of x plus log of x plus 3 equals 1. Well, I see two logs that are the same base, and there's addition in between the two, so I'm going to let addition on the outside make multiplication on the inside. I'm combining the two together, and that's a good thing because then I can change this from a log equation to an exponential notation. Logs always ask, what is the exponent? And there it is, the exponent is 1. 10 is the base, 1 is the exponent, and then all this is the power, which goes over here. Now, if you simplify things and bring them over to the right-hand side, you get x squared plus 3x minus 10. And if you factor it, you get that. And then your algebra skills lead you to believe that the two values could be negative 5 and positive 2. But you actually have to eliminate negative 5. Although it satisfies this equation algebraically, it doesn't satisfy the original. If you tried to put negative 5 in here and in here, you would get negative numbers. And you can't do that. It's not in the domain of log of x to put in negative numbers. So you have to eliminate it. It satisfies this immediate equation, but it doesn't satisfy the original. That's what happens when you take... So then you can see that here, if you plot the left-hand side and the right-hand side and figure out where they intersect, it's here at 2, 1, and only at one place, not at two different places. Here, we've got log of base 3. Sorry for the scribbling. We've got log of base 3. Log of base 3, the bases are the same, subtraction in the middle, so you can combine them to have division in between the two. 2x minus 1 over x minus 4. Log of base 3 of all this is equal to 2. Logs always ask, what is the exponent? And the exponent here is 2. The base is 3, so it's 3 squared is equal to all this. Now, if you multiply both sides by x minus 4 to get rid of the fraction, to clear the fraction, you get 9. 3 squared is 9. So 9 times x minus 4 is equal to 2x minus 1. Distributing and solving, you get x equals 5. Which you can also see on a graph. If you plot this, you see x equals 5 right here. What did I do? What did I plot exactly? I think I plotted this part right here. I plotted this left-hand side and this right-hand side. No, I plot the original, the left-hand side and the right-hand side. This is the right-hand side, 2, and the left-hand side is all of these logs that they give us at the very beginning. I don't know how you feel, but sometimes when I'm doing these, I feel like someone's pouring iodine on top of a cut and it hurts so bad. But actually, this math is a lot of fun. It does not feel at all like iodine being poured into a recently scraped knee. Iodine's your audio check fact of the day. It's the 53rd element on the periodic table. Example 9, we've got all of these logs. Wow, look at all, there's a ton of logs. Why don't we combine these two together, because I see subtraction in between the two natural logs, and so therefore that becomes division. And so the natural log of all this is equal to the natural log of all this. Well, if you're going to take two natural logs of something and let them be equal, then the originals inside must be the same. So anyway, another way to look at that would be to say I'm going to take both sides and raise them to the e power. E would cancel out the natural logs. Anyway, we have two natural logs in the same thing. So we've got 4x plus 6 over x plus 5. The inputs must be equal to each other. And from here on out, you got to solve like it's algebra. Multiply both sides by x plus 5, distribute, factor, and you get all that. Notice here, if you plot the two, like I plotted the left-hand side and I plotted the right-hand side. Let's see, this is the orange is the right-hand side and green is the left-hand side. They only intersect one place, and that's at x equals 2. You have to eliminate x equals negative 3 because it does not work in the original. It algebraically does solve this equation, but it's not a solution when you check it. It's not in the domain. So 2 is the answer. It's the only answer. And when you plug 2 in to either side of this equation, you get 0.693. Now, some of the equations are just algebraically not possible to solve. And they kind of look like this. An easy way to come up with an impossible equation, at least for us right now, is to say you've got a variable in both the exponent and not in the exponent, just as a polynomial here. It's not the decimals that make this impossible. It's the fact that if you take the log of both sides, it'll cancel out this e, but then you'll have the log of something of x, and that's going to be really difficult. And the only way to get rid of the log is to take it both sides, raise both sides to the e power, and you just have x's on two different levels here, and you can't solve. But you can solve graphically. Look, here is the right-hand side. The black is going to be 2.08x plus 6.2 right here, and then the left-hand side is going to be purple. And you can see one of the solutions is 6.61. Here it is. And the other solution, I want you to find. I want you to plug this into Desmos. I want you to find the solution, find the two values that make this the value. I want you to find the one solution down here that makes both sides equal to each other. You can find that graphically. And after you do that, I want you to begin 5e2. Copy the problem list and do the first problem. I will see you in class.